In the world of hyperscale data infrastructure, site selection is not just a matter of real estate. It's a silent, high-stakes conflict shaped by risk calculus, resource arbitrage, and infrastructure asymmetry. For those building or operating data centers, understanding the deep logic behind site selection is no longer optional, it's existential. We're not talking about subjective preferences or marketing pitches. We're talking about decisions rooted in grid topology, fiber density maps, legal precedent, and environmental science. Site selection today is a multi-layered optimization problem, one that spans engineering, finance, policy, and environmental resilience. Let's cut the marketing veneer. Behind every shiny new campus lies a brutal checklist. Where won't the power fail? Where will the water last? And where can we deploy capital without getting tangled in a decade of permitting hell? This isn't about expansion, it's about avoiding extinction. Welcome to the hidden war for data center land. Section 1: Energy Infrastructure. So, energy is the base layer of site selection. Every megawatt matters, and not just the dollar cost per megawatt hour. Technical due diligence now includes evaluating the stability of transmission nodes, redundancy models at the substation level, and time of use volatility. In Texas, ERCOT's open market model offers low-cost capacity, but that comes with reliability trade-offs. There's no interconnection with the eastern or western grids, which means outages are localized and unbuffered. Compare that with PJM, where congestion pricing exists but load distribution is far more resilient across state lines. Developers perform contingency analysis N-1, N-2 scenarios at the transmission and distribution levels, not just within the facility. Is the upstream substation dual fed? Is the feeder looped or radial? These determine whether your 5x9 SLA is a pipe dream. PPAs and VPPAs are now standard. Sites with proximity to wind and solar farms can lock long-term renewable energy prices, which are favorable for ESG reporting and investor relations. But without nearby substations with available interconnection capacity, those contracts are just theoretical. Load forecasting also matters. AI and high-performance computing HPC workloads cause burst demand spikes. Grid operators may not approve connection requests if your expected load curve is too unpredictable or peaky. Section 2: Fiber Connectivity and Latency. A dark fiber route is not a luxury, it's a hard requirement. Hyperscale tenants want sub-10 millisecond latency to major metros and failover routes built in. That means not only proximity to existing fiber corridors, but the legal and logistical feasibility of adding new ones. Right-of-way permits, railroad crossings, and utility pole attachments can delay a project 12 to 24 months. Smart site selectors review city and county records for recent telecom construction disputes. If the local telco plays hardball, your latency advantage may evaporate in regulatory trench warfare. Latency-sensitive applications like real-time analytics, financial transactions, and AI model serving have strict geographic bounds. If you're more than 30 milliseconds from your primary data pool, you're introducing systemic risk. Ashburn's fiber density remains unmatched, but it's oversaturated. New interconnection hubs are emerging in Columbus, Salt Lake City, and Atlanta, offering redundancy without the permitting gridlock. Microwave and LEO satellite connectivity are emerging as tertiary failover options in high-security architectures. Section 3: Climate and Environmental Risk. Climate resilience is no longer aspirational. Flood modeling, wildfire risk scoring, and seismic probability curves are built into modern site modeling tools. Operators now run Monte Carlo simulations across multiple environmental risk profiles before even contacting brokers. FEMA's 100 and 500-year floodplain maps are just the beginning. Smart teams layer NOAA climate projection data to model long-term sea level rise and storm path shifts. California's seismic zones and western wildfire hazard interfaces are increasingly redlined for greenfield builds. Insurance premiums often predict market retreat. If premiums double year over year, it signals actuarial models are seeing unacceptable risk trends. Providers like Munich Re and Swiss Re are now part of the early stage site selection intelligence loop. Local topography matters. Sites with insufficient drainage or those downhill from industrial runoff zones can become environmental liabilities. Permitting delays due to EPA or state level reviews can sink even well-financed builds. Section 4. Water rights and cooling strategy. Water is where things get real. Evaporative cooling remains efficient from a thermodynamic standpoint, but socially and politically, it's a hard sell in drought-prone regions. Closed-loop systems and direct-to-chip liquid cooling are growing in adoption. These systems drastically reduce water usage, but at the cost of added capex and complex maintenance. Their feasibility often hinges on local technician availability and vendor ecosystem maturity. In Nevada, groundwater rights are auctioned or grandfathered. In Arizona, adjudicated basins mean you could own land and have zero legal right to pump. In California, new regulation may cap industrial water draws. These are not edge cases, they're central to project viability. Water efficiency isn't just about gallons per megawatt, it's about timing. Pulling water during agricultural peak hours can spark political backlash. Data center operators now consult with local water boards and agriculture coalitions to negotiate sustainable draw schedules. Section 5. Regulatory and political risk. Zoning is not the only battle. There's also permitting fatigue. From CEQA in California to NEPA at the federal level, environmental review cycles are time bombs. Jurisdictional friction adds another layer. A county may approve your project, but the state environmental agency could delay your build by 2 years, or vice versa. Multi-agency coordination requires lobbying, legal pre-briefing, and sometimes public influence campaigns. Predictive political risk scoring is a rising field. Firms use machine learning to forecast approval timelines based on historic case data, political turnover, and media sentiment. This helps de-risk land options before LOI. Red versus blue doesn't always matter, but urban versus rural often does. Rural counties may welcome hyperscale jobs and tax-based growth, but fear resource strain. Engaging communities early with shared infrastructure incentives, like broadband expansion or road upgrades, can flip sentiment. Section 6. Emerging risk vectors. National security overlays are becoming more common. The U.S. Treasury and CFI-US are paying attention to foreign land ownership near critical infrastructure. Some land deals can trigger national security reviews if not structured carefully. Supply chain resilience is now a factor. Can the site receive equipment on time? What's the proximity to transformer manufacturers or specialized HVAC service providers? Logistics now directly affect time to revenue. ESG factors are evolving. Social metrics now include displacement of low-income communities and drawing municipal resources during shortages. Community benefit agreements, CBAs, are becoming more common to preempt opposition. Finally, the AI effect. Training clusters for large models can require tens of megawatts of burst capacity. The ability to add 20 megawatts in under 24 months is now a competitive differentiator. Sites are being evaluated on rampability, how fast you can scale up, not just what you can do on day one. Closing. So yes, site selection is war. It's fought in spreadsheets, zoning hearings, fiber trench plans, and on Capitol Hill. Every parcel of land is a vector of risk, and every bad assumption is $1 million mistake. If you're not modeling environmental stressors, political friction, grid instability, and fiber trench rights before the LOI, you're not picking a site. You're picking a land mine. Welcome to the hidden war. Pick your battleground wisely.